Hello guys, I welcome you all to my YouTube channel. In this particular video, we're going to learn about what is multivariate linear regression. In the previous videos, we have learned about simple linear regression. Now we're going to see what is difference between multivariate linear regression versus the simple linear regression. So in the previous videos, we have taken an example of a student, right? In the independent feature, it was the number of hours the student is studying, and in the dependent feature, it was how many GPA he is scoring. So depending upon the number of hours the student is studying, we were calculating the GPA of the student. So the GPA was only dependent on the one feature, that was the number of hours the student is studying. But now here in multivariate linear regression, the predicting value is not going to depend on one feature, it's going to depend on multiple features. So earlier the equation we derived was y equals to theta 1x plus theta naught, right? So here the it was x-axis and it was y-axis, and some line was like this. So here what we were saying, that given the x value, we were calculating the y value corresponding to this, right? Here if we give any x value, we were calculating the y value like this, right? But now the scenario is different. Now our solution of the y would not be depending upon only a single x-axis. It's gonna depend on two or more than two different values or different axes, I would say. So it is the case that we are not able to show you visually that what would be the relation between different axes simultaneously, right? So there can be many, like in 3D we can show you, but if the number of features are more than 3 or they are 4, 5, 6, then we can't show you. We only can see them theoretically. So if I draw a matrix for training data, that is x1, x2, x3, x4, something like this, and the features are x1, x2, x3, x4, like this. So this particular data point would be x11, x12, x13, x14. This is x21, this is x22, and here it would be something like xij. So it means this value would be ith data point and jth feature value, and corresponding to these values will be having y1, y2, y3, y4, like that, right? So we need to use these x values and we need to calculate the y values. So in the starting, we're going to train our model. So what is training here? Earlier what we were doing, if the equation was y equals to theta 1x plus theta naught in the initial, then what we were doing, we were randomly initializing the theta values initially, right? And then what we were doing, we were updating the theta values, we were calculating the new theta values, and then we were updating those theta values. So how the new theta value was calculated? The theta was theta minus learning rate and differentiation of loss function with respect to the theta. So this was the equation, right? And the same thing and the same theta update equation gonna be used here also. So how we're gonna use this particular equation on the multivariate features? So let's see. If I use this equation for a multivariate features, then it would be something like theta 1 x1 plus theta 2 x2 plus theta 3 x3, like that, plus theta n xn plus theta naught, right? This would be the equation for many features. And if I say, if I rewrite it again, theta n xn, then I can write theta naught x naught, and x naught can be said to be 1 for now, right? Then what we can derive here is x naught, x1, x2 till xn, and here theta naught, theta 1 till theta n, right? So it would be something like, if we multiply it, then it will be similar to this equation. So it will give us y. So y can be said as theta transpose x, right? As here theta naught would be 1, sorry, x naught would be 1 here, right? So here the y prediction value is theta transpose x, right? Now if I put The loss function would be similar here. There is no change in the loss function though. The loss function would be the same. The earlier the loss function was 1 by m y prediction minus y actual to the whole square, and it would be same here. So if we rewrite it again, then it would be theta transpose x minus y actual square, right? And this theta transpose can be rewritten like this, right? Now if we say the equation, now the loss function will be 1 by m theta naught x naught plus theta 1 x1 till theta n xn minus y actual to the square. Now we need to update every theta, theta naught, theta 1, theta n. We need to update every theta. So what we will be doing, will be updating theta 1 by 1. So for theta j, it would be theta j minus learning rate into differentiation of loss function with respect to theta j. So if you calculate the matrix of theta, then it would be theta 0, theta j till theta n. It's n plus 1 matrix, s plus n plus 1 cross 1 matrix, right? So in this way we're gonna update our theta for every theta values, right? So let's do it. We'll first calculate the theta j into loss function with respect to theta j. So the loss function we have derived was actually 1 by m theta naught x naught plus theta 1 x1 till theta n xn minus y actual to the whole square, right? So the loss function would be 2 by m theta transpose x minus y actual into, now if I want to do the differentiation of x naught theta naught x naught theta 1 x1 till theta n xn with respect to theta j, so if I give one value theta j xj, then only this theta xj would be the coefficient remaining, otherwise all are just a coefficient, so it all will be 0, and the differentiation of this particular equation with respect to theta j would be xj, right? So it would be xj, right? Because the differentiation of whole this equation would be only the coefficient of the xj, and this 2 can be adjusted in the learning rate. So if you see that value theta j minus learning rate would be differentiation would be by this is learning rate by m into theta transpose x minus y actual into xj, right? And for theta naught x naught would be, for theta naught x naught would be 1. So if we compare with the previous solution we were getting for this simple linear regression, which were theta naught was theta naught minus learning rate into uh, minus y actual, and theta 1 would be theta 1 minus n theta transpose x minus y actual x1. They are same because we can see it from here because x naught is 1. So this is our final equation for multivariate linear regression, right? I hope you got the clarity how we derived this equation using what we have learned previously in simple linear regression, and we implemented those formulas and all in this multivariate linear regression, right? So thank you so much for watching this video.